Bismillahirrahmanirrahim. So, as discussed in the last class, today we will be talking about the Newton's law of motion for rotational motion. Now, we already know the Newton's law of motion, right? Can you tell me the first law? Can anybody tell me the first law, Tariq?
A body will remain as it at its state forever until and unless a force is exerted.
Very good. Our body does not want to change its state unless a force is applied on it, right? So if you want to change the state of the body, you have to apply some force. Now, whenever we are talking about the state of the body, we are not actually referring to solid, liquid, and gaseous state. Okay, we are not referring to this state. Rather, we are referring to the state of motion, whether it is at rest or it is at in motion. If it is in motion, then what is its velocity? Okay, this is the state that we're talking about. So if a body is at rest, it will never become in motion by itself. Okay, if you want to make it come into motion, then you have to apply some certain amount of force on it, right? Okay, so this is the first motion and first law, and it also says that if a body is already in motion and if you want to change the velocity, then you have to apply some force on it, right? Now, the terms here is going to be changing like this. Till now, we were talking about linear motion, even though we do not mention the word linear, but till now, whenever we actually mentioned motion, we actually meant linear motion. But now it is going to be rotational motion, and we have to mention it. Okay, whenever we write motion, generally we mean linear motion. So in order to indicate to the rotational motion, you have to write the word rotational. Okay. So take a look at the first law. It says that, and also the force will become torque. Okay, force will become torque now, as we discussed in the last class. Every body persists in its state of rest or uniform rotational motion. Right. Whenever no force is being exerted on a body, what happens? It is in uniform motion. That means the velocity does not change. Unless it is compelled. Compelled means forced. Okay, to change the state by torque if pressed on it. So other than now, we will not apply force. We will be applying torque. Actually, whenever we apply force, then only we can produce the torque, right? Okay, but we cannot say that only applying force will be doing something unless this does not produce any torque. Okay. So this might sound a little bit confusing to you, sir. Even though I apply force, how it will not produce torque? There are some cases where you will see that you are applying force, but no torque is being produced. As I already told you in the last class that there is hinge of the door, right? And about that hinge of the door rotates upon application of some force, right? Now, torque is calculated by force into distance from the hinge or about the axis from about which the door actually rotates, right? So if you apply a force on the hinge, then what will happen? The distance from the hinge is 0 now, right? So even though you are applying force, you will not be producing any torque. And if there is no torque, then there will be no angular motion or rotational motion. So you see, even though you are applying some force, the torque is 0, and as a result, no velocity is being produced. Okay, so there will be no state of change of this door. So it is like that. Now the second one says the rate of change of angular momentum. Previously we knew that the rate of change of momentum we meant linear momentum. Okay, whenever we say momentum, that is linear momentum, but now we are talking about angular momentum. So it will be directly proportional to the applied torque, not force. Okay, it will be directly proportional to the applied torque, and the change of angular momentum will take place according to the direction of the applied torque. Okay. Then the third law says, in case of rotating body, the pair of particles engaged in action and reaction. Yes, the third law is the most popular law, and everyone, I guess, knows it that every action has an equal and opposite reaction. So whenever there is action reaction, generally there is at least two bodies involved, right? One will be giving the action force, another will be giving the reaction force, right? And these action reaction forces are equal and opposite to each other. Okay, now force is being replaced by torque here, so we will say that the torques will be equal and opposite to each other. See, this is what they are saying. In case of rotating body, the pair of particles engaged in action and reaction, the applied torques are equal and opposite to each other. Okay. So if you don't have any doubt till now, we can move to law of conservation of angular momentum. So before I move, I want to ask, do you have any doubt in these three laws that we have discussed so far?
No.
Okay, very clear, right? Very easy to understand if you can just remember to replace these words by them. Okay. Now, law of conservation of angular momentum. This also actually brings back the memory of studying the law of conservation of momentum. You remember two bodies used to be there, both are moving in the similar direction, and the velocity of the body which is behind, has a higher velocity. So as a result, what happens after some time, it comes and collides with the body at the front, and as a result, what happens? Their both velocity changes, and after changing, they keep moving still forward with some changed velocity. And from there, we actually developed this relation, this equation, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This was the conservation law of momentum. Okay. Now we are going to study conservation law of angular momentum. Let us see. From the first law of Newton's rotational motion, we know that if the external torque on a body is zero, it will rotate with uniform angular velocity, right? There will be no change of velocity because the torque applied is zero. Likewise, the force is zero in linear motion, the velocity will be uniform, right? But here we are going to say if the torque is zero, then the angular velocity will be remaining constant. If the angular velocity of the body remains constant, then its angular momentum also remains constant, right? Momentum is the product of mass and velocity. So mass is always constant, we know, unless we change the body. So here we are considering we are not changing the body, so the mass can be considered fixed. Now, if the velocity is also constant, then we can say mass into velocity, that is the momentum is also constant, okay? In other words, the torque applied on a body is zero, the angular momentum is conserved. Yes, the total torque applied on a body, if it is zero, then what will happen? The mass will not change, the velocity will not change. As a result, the momentum will also not change. Okay, this is called the law of conservation of angular momentum. This can explain further in the next page. So come to page number 232. Let us go through the statement first. If net applied torque on a particle is zero, net torque applied. Previously, it used to be the net force applied on an object. Okay. In actually SSC level, we read that if no force is applied on a body, that means F is equal to zero. We used to consider in SSC level that F is equal to zero. But since we have started studying in HSC level, we have seen that there is a change, a little bit of change in the law. That is, now we say the net force applied on object is zero. What is the difference between that? The first situation says that there is a body and no force will be acting on it. Okay. But the second case says that there will be some forces acting on the body, but they will be balancing each other. So the net force applied will be zero. We can say that the net force applied will be zero here. Do you understand my point? Okay. This is more accurate. Okay. Because this is true when, even though there are forces, if they're balancing each other, then this law is applicable. Okay. So here we will say if the net torque on a particle is zero, then its angular momentum is conserved. This is our law. Okay. Now let us see how we can prove it. If the moment of inertia of a particle is I, angular velocity is omega, and angular momentum is L, we already know that L is equal to I omega, right? In the second class, we studied this one. If you remember, L is equal to I omega. Okay. Now differentiating with respect to time. So if I differentiate it with respect to time, d dt L d dt I omega, right? Okay. So if you remember here I, this is going to be constant, so it will be coming out then it will be T dt. Sorry, I am right first, and then it will be T omega by dt. Now omega is angular velocity. So ddt means the rate of change of omega is angular velocity. So the rate of change of angular velocity is angular acceleration. That is I alpha. Okay, I is there and the omega dt, this becomes alpha. If you remember, okay, velocity, this is the differentiation of the displacement, and acceleration, this was the differentiation of the velocity. The rate of change of velocity with respect to time, that is acceleration. Now we have, in case of linear motion, we have angular motion. So that is why angular acceleration. Okay, till now anybody have any doubt? No.
No, sir.
So, in the last class, we also discussed about this, that tau is equal to I alpha. So, can I replace it by tau? If I replace tau here, then what is happening? We are getting dl dt is equal to tau. dl dt is equal to tau. Now, from the law, we can see that we are saying that net torque applied is 0. So, if this torque here is equal to 0, then we can write dl by dt is equal to 0. Now, what does this mean? ddt means the rate of change. L is the angular momentum. Now, the rate of change of angular momentum is 0. That means it is not changing. That means we can say that L is remaining constant here. Do you understand my point? ddt, this says the rate of change. L is angular momentum. So the rate of change of angular momentum is 0. When the rate of change of something is 0, that means that thing is not actually changing. So as a result, we can consider that that thing is constant. Or else, if you remember, in the law, while we studied the laws of the differentiation, we saw that whenever we differentiate a constant value, let us say 3, it is a constant value, right? So whenever we differentiate a constant value, we get 0. So we can say that if differentiating anything, I get 0, then that thing is a constant. Okay, just in the opposite direction, we can say this. Anybody has any doubt that L is equal to constant? So we have proved that if net torque is applied is 0, then we can say that angular momentum is going to be conserved. If anybody have any doubt, then this is the time to ask. Nobody? Sadia?
No, sir.
Okay, Saiful? Saiful, are you there? Do you have any doubt? সাইফুল ঘুমাইছো দেখি তো তোমার ক্যামেরা অন করো তো দেখি এই সবাই সবার ক্যামেরা অন করো বলছ না স্কুল থেকে রুলস বলে দেওয়া সবার ক্যামেরা অন রাখতে হবে তোমরা কি ক্যামেরা অন করতেছো না সো আমি জানি না তোমরা কেউ ঘুমাচ্ছ কিনা আমি তো দেখি তোমরা সবাই ঘুমাচ্ছ কিনা আচ্ছা so then we have the centripetal and centrifugal force okay these forces are generated when a body is in circular motion okay let us say we have a rope here okay one end of the rope is attached to one of my finger okay and another end is tied to a ball now if I start rotating it like this then what will happen the ball will be in a circular motion right now when the body is in circular motion you will always feel that the body wants to go out of this circular path right if you cut the wire you will see that the body is not remaining in circular path anymore rather it is going in a straight direction it is having a linear motion right but as it wants to be in linear motion but if you want to keep it in a circular path you are having to apply some force on it right that means towards the center through the wire or through the rope towards the center you are applying a force right what is that force that force is called centripetal force centripetal force Now, why this force is actually necessary? Because you will see that whenever a body is in a circular path, okay, it feels a force towards outside of the circle. Okay, it is towards the opposite direction of the center. Okay, along the radius it is just the opposite. Now to balance that force, we need to apply a force that is called centripetal force. Now what is that force, outward force called? That force is called centrifugal force. Centrifugal force. Now, this force we have, we have been experiencing throughout our life. Whenever we ride a vehicle, okay, and the vehicle actually passes through a curvy road, okay, you cannot actually go through this road at a high velocity. Can you imagine it? If you go through this road at a high velocity, then your car will topple down out of the road. It will be thrown out of the road. Okay. Here, driver has to control the velocity and go slowly so that he can stay in this curvy path. Okay, or else he will go out of the road. Now that is the force that he feels actually, which will throw him out of the road, is actually centrifugal force. Okay. Now to balance this centrifugal force, we produce a centripetal force. Okay, that works towards the center. Now in road, you might be thinking that okay, let us consider this one as a circular path and our car here is like that ball. Okay, so we understood that a centrifugal force is being generated on the car, so and as a result the car, you feel like the car is going to be thrown out of the road, right? But it does not happen. Why it does not happen? Definitely that centrifugal force has to be balanced by a centripetal force, right? But do you see any rope that attaches the car to the center of the road? There is no rope like that, right? Then how it happens that the car does not actually go out of the road even though the centrifugal force is acting on it? Actually, a centripetal force works. How this centripetal force is generated and how it works, inshallah, we will see it in the next class. Okay? For so that it becomes easier for you to understand when I explain, I would like to request you to go through it beforehand. Okay? Just go through the pages. Just read the line. Just read the line. Okay? No need to try hard to understand it. Just go through the line. Okay? That will make your understanding easier when I discuss it in the next class, inshallah. Do you understand my point? We will inshallah study about banking and angle of banking. Okay, this is very important for mathematics, for numerical problems of this chapter. A lion part of the numerical problem will be involving the formula that we will learn in angle of banking, inshallah. Okay, so please nobody inform your friends so that they do not miss the next class. Okay, today the attendance is less, I feel. Okay, no problem. Just tell them so that nobody misses the next class. Okay. And before we end today's class, anybody has any question to ask regarding what we studied today? Anybody has any questions to ask?
আমাদের ক্লাসে স্যার শুধু এই কয়টাই স্টুডেন্ট আর কেউ নেই। এই ক্লাসে শুধু এই কয়েকটাই স্টুডেন্ট আর কেউ নেই।
আরো দুইজন আছে বলে আমি জানি, তোমরা 7 জন, এখানে টোটাল 9 জন না?
স্যার এই আবির তো লিভ করে দিয়েছে স্কুল।
আচ্ছা, আবিরকে
চলে গেছে না?
আচ্ছা ওকে, যাই হোক, তোমরা যদি হতো তাহলে তোমরাই। ওকে, তো ঠিক আছে, তোমরা একটু এক্সট্রা টাইম পাচ্ছ রেস্ট করার জন্য। ওকে, তো নেক্সট ক্লাসে দেখা হবে ইনশাআল্লাহ। ভালো থাকো সবাই। আর ক্লাস যদি কোনোভাবে মনে হয় যে স্যার আরেকটু ডেভেলপ করা যায়, তো তোমরা অলওয়েজ সাজেশন দিতেই পারো। ঠিক আছে, আসসালামু আলাইকুম ওয়া রাহমাতুল্লাহি ওয়া বারাকাতুহু।